Sample problem 312. Alka-Seltzer tablets contain aspirin, sodium bicarbonate, and citric acid. When they come into contact with water, the sodium bicarbonate, NaHCO3, and citric acid, H3C6H5O7, react to form carbon dioxide, among other products. The formation of carbon dioxide causes the trademark fizzing when the tablets are dropped into a glass of water. An Alka-Seltzer tablet contains 1.700 grams of sodium bicarbonate and 1.000 grams of citric acid. Determine, for the single tablet dissolved in water, A, which ingredient is the limiting reactant, B, what mass of the excess reactant is left over when the reaction is complete, and C, what mass of carbon dioxide forms. So we have a lot to do in this problem, and these are compounds that you would find in Alka-Seltzer. So sodium bicarbonate along with citric acid. So let's do the following. I'm going to go ahead and calculate all of the molar masses. So let's begin with sodium bicarbonate. Okay, there's one sodium, there's one hydrogen, there's one carbon, and there's 3 oxygens. Okay, so let's figure out what that is. NaHCO3. 22.99, 1.01, 12.01, 3 times 16.00, 84.01. Remember, the units of molar mass are grams per mole. Okay. Now let's do the citric acid. Citric acid is H3C6H5O7. So there's a total of 8 hydrogens. Now you might ask, why do they put 3 hydrogens at the beginning and then put another 5 in the middle? That's to tell us that this is an acid. Okay, so 8 times 1.01, 6 times 12.01, and then 7 times 16.00. Okay, 8 times 1.01 plus 6 times 12.01 plus 7 times 16.00. 192.14. And again, that's in grams per mole. So those are the reactants. Now, there's only one product that they ask us about, and that's the carbon dioxide. So we'll do that one. 1 carbon, 2 oxygens. This one we can do without a calculator. Okay, so we've got our molar masses of the 2 reactants that we need to consider and the 1 product that we need to consider. So now let's do a little bit of calculations. So we've got 1.700 grams of sodium bicarbonate. Okay, so what I'm going to do is I'm going to find the moles. Okay, so 1.7 grams. That's the mass of sodium bicarbonate. 1 mole of sodium bicarbonate is 84.01 grams. Okay, so that's going to tell us how many moles of sodium bicarbonate we have. .0202. And that's sodium bicarbonate. Now we do the same thing for the second reactant, which is the citric acid. Oops. Let's redraw that. Okay, so the mass is only a gram, 1 gram. And 1 mole of that substance is 192.14 grams. Okay, so 1 gram over 192.14. Okay, smaller, right? 0.00520. Actually, let's do this. That's 3 sig figs. I'm going to try to get one more 0.5. Okay, so there's our moles of each of the reactants. Okay, now what I'm going to do, and by the way, so many of these problems that you do, those are the first 2 steps. You find the molar mass of everything, and then you convert each one of them to moles using the molar mass, right? Those first 2 steps is the first 2 steps of so many different types of problems. Okay, the next step is to find out how many moles of carbon dioxide are going to be formed. To do that, we have to consider the moles of the reactants, okay? And we also have to consider the balanced equation. So it's 3 to 1 to 3. It's 3 moles of citric acid for every 1 mole sodium bicarbonate. Oops, did I get that wrong? It's the other way around. It's 1 mole of citric acid for every 3 moles of sodium bicarbonate. My apologies. Let me get rid of that mistake. Okay. It's 3 moles of sodium bicarbonate. Oops. For every 1 mole citric acid. And then for carbon dioxide, it's 3 moles. 3 moles CO2. Okay, you see where these numbers come from, right? The 3 is the coefficient in front of sodium bicarbonate. Think of a tricycle. In a tricycle, you have 3 wheels. 3 wheels for 1 frame. That's what those numbers are telling us. 3 moles of sodium bicarbonate are required to react with 1 mole of citric acid, which will produce 3 moles of CO2. Okay? So here's what I'm going to do. I'm going to use each of these in a separate calculation, 2 separate calculations to find the moles of this one. And then I'm going to pick the smaller number. That's the logic that I'm using. So here's the idea. You have, or we have, 0.0202 moles of sodium bicarbonate. We just calculated that. And it's 3 moles of CO2 for every 3 moles of sodium bicarbonate. Right? It'd be like this. If I said, hey, I have 3 wheels, how many tricycles can I make? It's 1. I mean, 1, right? Like essentially, you get 3 carbon dioxides for every 3 sodium bicarbonates that you put in. Well, we didn't put in 3, we put 0.0202. So I'm going to cancel the units, and we get 0.0202 moles of CO2. So that's how much CO2 we would produce if all of this reacted. The problem is we don't know if all of it's going to react. There may not be enough citric acid to react all of the sodium bicarbonate. So we do a separate calculation. We take the moles of citric acid Now I'm going to put this into scientific notation. Okay, see how I did that? I put that in scientific notation. That's this number up here. And then it's 3 moles of CO2 for every 1 mole of citric acid. Okay. So we're just going to take that number, moles of citric acid, multiply it by 3. We may have that in the calculator here. See, it's still in the calculator, so just multiply it by 3. 3 divided by 1 if you want to be technical about it. And you get 0.01561. 0.01561. Okay, right? Moles of citric acid cancel. You have moles of CO2. Which one's smaller? 0.02 or 0.01? 0.01 is smaller, right? So there's our answer. That's the number of moles of CO2 that are going to be produced. Now, where did that smaller number come from? It came from the citric acid. That tells you this is the limiting reactant. The limiting reactant is the reactant that gives you a smaller amount of product. Okay, so there's our answer right there for moles of CO2. Now they want to know the mass of the CO2, so I'm going to calculate that next. 0.01561 moles of CO2, and it's 44.01 grams per mole for CO2, right? We did that at the beginning, 44.01. That's all the way up here. Okay. So we're going to take that smaller number of moles of CO2, multiply it by the molar mass, so times 44.01, and it's 0.687. There's the second part of our answer. We have 2 answers now. Oh, I'm sorry. This is the second part. The first part answer was this one over here, which is the citric acid is the limiting reactant. That's the one that gives you the smaller number. Again, here's the analogy, or here's an analogy. If you're making sandwiches and you have 25 loaves of bread, but you only have 1 slice of cheese, you can't use all of the bread to make the sandwiches. If you need 2 slices of bread for every sandwich and 1 slice of cheese, there's only enough cheese to make 1 sandwich. So it doesn't matter how many slices of bread you have. It's the limiting reactant would be the cheese. That's what determines how many sandwiches you can make. Same thing happens here. Because the amount of CO2 we could produce was smaller using the citric acid, that's the amount that will be produced. Now we have one more part, and the wording of the question was a little bit complicated. What we've done is we've answered 2 questions, but we haven't gone in the order that they wanted us to. Well, not that they necessarily care. What mass of excess reactant is part B? We haven't answered that. What mass of excess reactant? But we do know that that's the sodium bicarbonate at least. How much is left over when the reaction is complete, right? So what we can do is we can ask ourselves, how much sodium bicarbonate is used when we make 0.687 grams of CO2. And then I'll go through the logic in a moment, but let's do this calculation first. The CO2 that got produced was 0.01561 moles. That's how much we produced. The production of CO2 has 2 requirements, at least 2 requirements, but 2 that we can quickly identify. One is citric acid. Without the citric acid, there's no CO2. Just in the same way that if there's no flour, there's no cookie. But we also need sodium bicarbonate to make the CO2. We also need sugar to make a cookie. So if one of those ingredients is not there, we don't make a cookie or we don't make carbon dioxide in this case. So all we have to do is we have to say, okay, if we make this number of moles of CO2 right here, how many moles and how many grams of sodium bicarbonate would be used for that? So we come back to our ratios again. The ratio says that there are 3 moles of sodium bicarbonate used for every 3 moles of CO2. So that's pretty good. So that means we just say 3 moles of sodium bicarbonate. Oops, that's supposed to be an N. For every 3 moles of CO2. Moles of CO2, and you get 0.01561 moles of sodium bicarbonate used. Okay, I'll underline used, meaning in order to make 0.687 grams of CO2, we had to use a certain amount of sodium bicarbonate. That number right there is how much we used. Now, if you think about it, we started off with 1.7 grams. I forget whether it was 2 zeros or 3 zeros. It was 1.700. That's how much we started with. Right? All we have to do is subtract from that the amount used. And that'll give us the amount remaining. Right? If I start off with 1.7 grams and I use 1 gram of it, the amount left is 0.7 grams, just the difference between the two. Well, we have the amount used, it's just it's not in the right units, it's in moles and not grams. So let's just convert it into grams. 0.01561 moles of sodium bicarbonate. How do we convert that to grams? Multiply it by the molar mass. See how that molar mass calculation and converting between grams and moles is so important? It just comes up over and over. So 0.01561 times 84.01, oops, 0.01561 times 84.01, looks like it's about 1.31 grams. Might be 1.311 grams, sorry. 1.311 grams. So that's the amount used right there. So the amount remaining would be what we started off with, 1.700, minus the amount that we use, 1.311 grams. And that looks like, was that 0.389? You can check that. Check that on your calculator. Something like that. And there's our answer. So we've got 3 answers. This is actually part B, but I'll write that down as our third answer. There's three questions that were asked. We've answered them all. The limiting reactant is the citric acid. The amount of carbon dioxide produced is 0.687 grams. And the amount of sodium bicarbonate that's left over is 0.389 grams. Now, most likely, what happens is, in the stomach, your stomach has acid. That might be the reason you're actually taking this antacid, right? Is because your stomach is so acidic, it's irritating the tissue, the lining of your stomach. So you take some antacid. So there's actually already acid in there. So the citric acid, some of it's going to react. But the remaining sodium bicarbonate is just going to react with the acid that's already in your stomach, which is hydrochloric acid, actually. And so it will get used up eventually. But the point is that if you just had these 2 reactants, you would have some sodium bicarbonate left over. And that's your limiting reactant problem.